Welcome to Cardano for Everyone, a podcast series from Pasta Steak Pool. Each episode explores something new about Cardano in a way that's simple and accessible for everyone. In the mood for some Cardano magic? Let's get started.
Ready to dive deep into Cardano. This time, it's the Goguen phase. We're talking smart contracts, the whole shebang. Got a ton of sources, so let's get to it.
Goguen was a game changer. Byron and Shelley, the phases before were like setting the stage, building the network, getting that decentralized system running.
Yeah, the groundwork, right?
Right. Then Goguen hits, and suddenly anyone can build on top of it. Applications, agreements, the whole 9 yards.
Like going from, I don't know, a flip phone to a smartphone, endless possibilities.
Exactly.
But hold on, you mentioned Cardano's architecture is, unique.
Oh, absolutely. It's built in layers. Each layer has a job, and they all work together. At the bottom, the Cardano settlement layer, the CSL, that handles all the ADA transactions, getting your ADA where it needs to go. Then, on top of that, the Cardano computation layer, the CCL. That's where the smart contracts live.
Gotcha. So CSL is the nuts and bolts, and CCL is where things get interesting.
Keeping ADA transfers separate from the smart contracts, that's huge for scalability and security. Plus, you've got the network layer for communication between all the nodes and the consensus layer where Ouroboros comes in.
Ouroboros. Cardano's proof of stake, right. Way more energy efficient than Bitcoin and its proof of work.
Clever algorithm to make sure everyone agrees on the blockchain state. And no energy hogging.
Awesome. So layered cake? Now, Goguen itself wasn't just one event, right?
Nope. It was rolled out in 2 major hard forks, Mary and Alonzo. First, Mary, back in March 2021. That introduced the multi-currency ledger. Before Mary, only ADA on the blockchain.
Just ADA.
But with the multi-currency ledger, anyone can create their own tokens alongside ADA. No need to build a whole separate blockchain.
So Mary was like, let's tokenize everything. Huge.
Then Alonzo hit in September 2021. This is the one that really shook things up. Alonzo brought smart contract functionality through Plutus.
Plutus. That's Cardano's smart contract language. Based on Haskell, right? Why Haskell? What's so special about it for smart contracts?
Well, Haskell, maybe not the most popular language, but it's known for being secure, reliable. It's got this strong typing system, emphasis on immutability. All that means fewer errors, and the code does exactly what it's supposed to. And that's crucial when you're dealing with, valuable stuff on a blockchain.
So like the Fort Knox of programming languages, built for security.
Exactly. Alonzo also brought the Plutus platform, a whole bunch of tools and libraries to help developers build dApps using Plutus.
So that's pretty technical.
Think of it like building a house. You've got the foundation, walls, roof, plumbing, wiring. All these parts need to work together. The Plutus platform is like that for building dApps, so developers can actually write the smart contracts.
Gotcha. So Plutus platform provides all the building blocks. But then there's Marlowe. That's specifically for financial contracts, right?
Right. Marlowe's like a specialized tool for financial contracts, like, having specific power tools for woodworking. It's more accessible. It's got a visual approach. So no writing code. You drag and drop elements like building with virtual Legos.
Wow. Sounds super user-friendly. So Plutus for the hardcore developers, Marlowe for the finance pros.
Exactly. Different needs, different skill sets. They work great together.
This is fascinating stuff. We've covered the basics of Goguen and smart contracts, but every tech advancement has its bumps in the road. What were some of the challenges with Goguen?
Well, one of the biggest, like with any blockchain, is scalability. More people, more dApps, more transactions, the system can get bogged down.
Like rush hour traffic on the blockchain.
They tackled it from different angles, optimized the Plutus script execution. They also improved memory management on the blockchain itself, like decluttering a house, more space, more organized.
So making it lean and mean to handle all those transactions.
Yep. And they're looking at layer 2 scaling solutions, like building express lanes on a highway, bypass the traffic jams. These layer 2 solutions can make transactions faster and cheaper by processing them off the main chain, Hydra, for example. Still under development, but really promising for Cardano scalability.
Hydra, wow. Sounds powerful. So easing congestion, keeping things moving. But scalability wasn't the only hurdle, right?
No, there was the developer experience, especially with Plutus. Remember how we talked about Haskell being super secure, but also a bit challenging to learn? So to help, Cardano launched the Plutus Pioneer Program. It's like a boot camp for developers. Teaches them how to build dApps using Plutus step by step. They also made the Plutus documentation way better, more comprehensive, user-friendly, and they created the Plutus Playground, a web-based environment where developers can, play around with Plutus code, test contracts, build prototypes. No need to set up a whole development environment. Like a virtual sandbox.
Awesome. Lowering the barrier to entry for developers, giving them the support they need.
They're always working to make it easier for developers because attracting good developers is crucial for Cardano's future.
Makes sense. Okay, we've talked scalability, developer experience, but we can't forget security, right?
And Cardano takes security super seriously. They use formal verification methods.
Formal verification, remind me what that is.
Imagine building a bridge. You don't just weld metal together and hope for the best. You use calculations, simulations, to make sure it can handle the stress. Formal verification is like that for smart contracts. Math techniques to prove the contract does what it's supposed to do, with no hidden vulnerabilities for hackers to exploit.
Okay, like a team of engineers stress testing the bridge before it opens.
Exactly. Cardano uses formal verification throughout the whole development process. For Plutus and Marlowe, mathematical proofs to make those smart contracts as secure as possible.
Wow, that's impressive. Not just testing, but mathematical guarantees.
That's a big reason why Cardano is considered one of the most secure blockchains out there.
Okay, so far we've covered a lot. Cardano's layered architecture, the move to decentralization with Shelley, and now smart contracts with Goguen, Plutus, and Marlowe. Starting to get a good grasp of things. The multi-currency ledger, you mentioned it earlier. What's the big deal with that?
The multi-currency ledger from the Mary hard fork lets you create native tokens alongside ADA on the Cardano blockchain itself. So anyone can create tokens for specific purposes. Loyalty programs, digital art, even representing real-world assets, all within Cardano.
So it's not just ADA, it's a whole universe of tokens. And what about DPKI? What does that even stand for? How does it fit in with Cardano?
DPKI, that's Decentralized Public Key Infrastructure. It's about managing digital identities and their keys, but in a decentralized way, like a digital passport system, but no single authority controls it.
Okay, so more secure, more transparent way to handle digital identities.
And Cardano, with its layers and smart contracts, is perfect for building a DPKI system.
Very cool. Okay, now for a really complex one. Cryptographic accumulators. What are those all about?
These are like mathematical magic tricks. You can take tons of data, like 1 million names, and represent it with a single short code.
Wait, 1 million names in one tiny code? How?
It's pretty mind-blowing. And with that code, anyone can check if a specific name is on the list without needing the whole list. Cardano uses these in different parts of the protocol to make things more efficient and secure, like verifying transactions quickly or managing the blockchain state in a compact way.
It's like a secret code to prove membership. Super efficient, super secure. Amazing. Okay, so we've got the multi-currency ledger for all kinds of tokens. DPKI for secure identities, no central control. Cryptographic accumulators for efficient verification. That's a lot to process.
It is, but it shows you how carefully Cardano is designed.
Definitely. Feeling like we're getting a real understanding of this tech.
But there's still so much more to unpack.
Before we jump into that, I'm really curious about the EUTXO model. You mentioned it's different from the account-based model most blockchains use. What's the deal with that?
Okay, so think of it this way. In the account-based model, your wallet is like a bank account. It has a balance, and every transaction updates that balance.
Yeah, makes sense. Pretty standard way to think about money, right?
But the EUTXO model, which stands for Extended Unspent Transaction Output, that's a different beast. Instead of one balance, your wallet holds a collection of unspent transaction outputs, UTXOs.
UTXOs. So it's not a total balance, but like individual bits of ADA from past transactions.
Exactly. Each UTXO is like a separate coin. When you make a transaction, you pick specific UTXOs from your wallet, maybe combine some, and then create new UTXOs that show the new ownership. And the extended part of UTXO, that means these UTXOs can hold extra data, even simple scripts. Adds a lot of flexibility.
Okay, interesting way to handle things. But why did Cardano go with UTXOs instead of the, more common account-based model?
Well, it has some serious advantages. For one, it's great for parallelization. meaning lots of transactions can be processed at the same time. Each UTXO is independent, so transactions using different UTXOs don't have to wait in line. They can all be processed together, making the system much more scalable.
Ah, I see. Like having multiple checkout lines at the supermarket instead of everyone stuck in one queue.
Another plus is security. Each UTXO is linked to a specific transaction. It has a clear history that creates a detailed audit trail. Makes it really hard to mess with transactions or steal funds.
Like a security camera tracking every coin.
And finally, EUTXO gives you more flexibility when you're designing smart contracts. Because UTXOs can carry data and scripts, you can create more complex and nuanced smart contracts. Opens up a lot more possibilities.
So scalability, security, flexibility sounds pretty good.
And then there's privacy. Because every UTXO has this clear history, it could be easier to trace the flow of funds, see who's involved in transactions. But Cardano is working on privacy-enhancing technologies, like zero-knowledge proofs and confidential transactions, trying to reduce that risk.
So finding that balance between the transparency and security of EUTXO and, keeping things private for users.
It's all about finding the right balance.
Okay, starting to get the ins and outs of UTXO now. Thanks for explaining that. But before we move on, can we circle back to formal verification? We touched on it earlier when we were talking about security, but it seems like such a crucial part of Cardano's development process that it deserves a little more attention.
Remember, formal verification, it's that process where you use math techniques to prove a system is doing exactly what it's designed to do. It's like having a whole team of math experts double-checking every line of code, making sure there are no hidden bugs or vulnerabilities that could cause problems. And choosing Haskell for Plutus, that helps too. Haskell, with its strong typing system and focus on immutability, it makes it easier to create those formal proofs.
They're not just throwing together a blockchain. They're creating this incredibly robust and secure foundation. But with all this talk about the technical side of things, I'm curious to know more about the real-world impact of Goguen. What did all these innovations actually enable? What's been happening out there in the real world?
Look at the dApps that have emerged, the growth of the Cardano community. But the real magic of Goguen, it's what all that enabled, the ability for anyone to build these decentralized applications, dApps, all powered by smart contracts.
Right, dApps, applications that run on a decentralized network. No single entity controlling them.
And Goguen, by bringing in smart contracts, it basically opened the floodgates to this whole new world of possibilities. Developers could suddenly create dApps that interact with real-world assets, automate complex agreements, even invent entirely new ways of doing business.
Okay, enough with the hype. Give me some specifics. What kind of dApps are we talking about? What did Goguen actually make possible in the real world?
Well, one of the biggest areas is DeFi, decentralized finance. Goguen made it possible to build dApps that offer all sorts of DeFi services, like decentralized exchanges, where you can trade crypto directly with others, no need for a centralized exchange, or lending and borrowing platforms. You can lend your crypto to earn interest or borrow against it, all managed by smart contracts, transparent and automated.
So it's like taking the traditional financial system and turning it upside down. No more gatekeepers, no more middlemen, just people interacting directly through these dApps.
And the great thing is, all of this is happening on Cardano, so it inherits all that security and reliability we talked about.
It's not just decentralization for the sake of it. It's about making the whole financial system more efficient, more transparent, and more secure.
You got it. But DeFi is just the beginning. Goguen has had a ripple effect across so many industries. Think about supply chains, where you could track a product from its source all the way to the consumer. Complete transparency, ensuring authenticity every step of the way. Huge implications for things like fighting counterfeit goods and promoting ethical sourcing. And then there's healthcare. Imagine dApps, where patients control their own medical records, deciding who has access to their data, putting individuals back in control of their own health information. More privacy, more control.
Yeah, data privacy is such a big deal these days. That's a really important application. What else? What other areas has Goguen had an impact on?
Honestly, the possibilities are almost endless. We're seeing dApps for voting, making elections more secure and transparent, dApps for gaming, where players can own and trade in-game assets, even dApps for identity management, creating a more secure and decentralized way to verify identities. And the more developers join Cardano, the more creative and impactful dApps we can expect to see in the future.
How did Goguen affect the Cardano community?
Well, As developers started coming to Cardano to build these dApps, the community just exploded from all over the world, each bringing their own skills and perspectives. And this influx of talent and energy, it created this incredible ecosystem, collaborative, supportive, people sharing ideas, launching projects. That whole spirit of decentralization, it really thrived.
It's like this positive feedback loop, right? The tech leads to innovation, which attracts the community, which fuels even more innovation. So much belief in the power of decentralization. But as we wrap up our exploration of Goguen, I want to take a step back and ask, what does it all mean? What's the lasting impact of Goguen? It's more than just code and dApps, right?
The real measure of Goggen's success, it's not just about the tech, it's about empowering people, individuals, and communities. By building this platform that's secure, sustainable, and accessible to everyone, Goguen has created this foundation for a future that's more decentralized, more equitable, more inclusive. A future where power shifts away from those big centralized institutions and back into the hands of the people.
That's a powerful thought. Remind me, what were those key advancements from those earlier phases that even made Goguen possible?
Well, Byron, that was kind of the groundwork. It focused on the core ADA transactions, but it was really Shelley that set the stage for Goguen. And they did that by bringing in Ouroboros, Cardano's proof of stake protocol.
This is where things got interesting.
And that shift to a more decentralized, energy efficient system, it was crucial to make way for Goguen and make sure that the platform could handle all the complexity and all the transactions that come with smart contracts.
So if you're a developer and you want to build an app, a decentralized application, you'd use Plutus to write the smart contracts.
Plutus gives those developers the tools they need to create, all kinds of really cool dApps.
I'm starting to get how Goguen opened up all these new possibilities for Cardano. But what was the impact like on the Cardano ecosystem? Did we see all these new projects, applications popping up?
Oh yeah, definitely. When they introduced native tokens with Mary, and then of course the full smart contract capabilities with Alonzo, it really sparked a wave of innovation on Cardano.
So what kind of projects started popping up? Give me some examples. What were people building?
Well, suddenly you could create lending and borrowing platforms, decentralized exchanges, stable coins, all kinds of financial instruments, and they're all running on the Cardano blockchain without needing those traditional intermediaries.
Wow. So instead of going through banks or these big institutions, people could interact directly with each other through these decentralized applications. That's a huge shift.
And because Cardano's smart contracts are built with security and reliability in mind, these DeFi applications could operate with a higher level of trust and transparency.
But with all this activity happening on the blockchain, did it impact Cardano's performance? Did things slow down or get more expensive as more dApps were built?
That's a great question. It's something people worry about with blockchains as they grow, but this is where Cardano's architecture really shines. That layered architecture we talked about.
Yeah, like the settlement layer for ADA transactions, the computation layer for smart contract, and the network layer for communication.
Separating these different concerns means each layer can be optimized without messing with the others. It's like having different expert teams working on different parts of a car engine, right? Each one making sure their part works perfectly, but also that they all work together smoothly.
So Cardano was built with scalability in mind from the start.
From the very beginning.
Okay.
Which is why it's been able to handle the increased demand without sacrificing speed or efficiency.
Impressive. How does Cardano's extended UTXO model differ?
Well, it takes that idea further. It lets you attach complex scripts, like mini programs, to these UTXOs. These scripts can set up specific conditions that have to be met before the coins can be spent.
But how does that benefit the everyday user?
Okay, so this approach brings several advantages. One is security. Since the logic of the smart contract is tied to the UTXO, it's really hard for someone to mess with it or exploit it. Also, it makes transactions more predictable. The outcome is all based on that predefined script, so you eliminate uncertainty and potential errors.
It seems like the extended UTXO model is a big part of why Cardano's smart contracts are so secure.
Definitely.
But I'm curious about those cryptographic elements we touched on earlier, like DPKI and cryptographic accumulators. Remind me what those are and why they're important.
So DPKI, which stands for Decentralized Public Key Infrastructure, it's all about trust in the network. It's a secure, distributed way to manage digital identities and public keys. So, you can verify that users and their transactions are authentic
So like a digital passport system.
and make sure everyone is who they say they are.
What about cryptographic accumulators?
A cryptographic accumulator lets you prove if a specific piece of information, like a public key, is part of a bigger set, but you don't have to store or reveal the whole set. It's
Right.
like being able to check if you're on a guest list without seeing the whole list.
So efficiency and privacy.
It's a way to make sure the whole system stays secure, even when different components are combined. Like, imagine you're building a car. UC is like making sure each part not only works perfectly on its own, but that they all function seamlessly when they're put together.
So it's about ensuring the whole system remains secure, even in like these complex situations. This has been like a seriously deep dive into the technical side of Cardano.
It has.
It's amazing how all these pieces work together to make this secure platform. But gotta admit, all this talk about UTXOs and these cryptographic accumulators, is there like a simpler way to explain how this benefits everyday users like me?
All this tech stuff, it's working behind the scenes to make things more secure, efficient, easier to use. Like, remember that DPKI system we talked about? That protects your identity and your funds when you're using dApps. And those efficient cryptographic accumulators, they help keep transaction fees low and the network running smoothly.
What about developers? You mentioned Plutus can be a bit tough to learn. How is Cardano making it easier for developers to build on the platform?
Well, they've been working on creating a really supportive ecosystem for developers. Like, they have in-depth training programs, they're always coming up with new tools and resources, libraries, documentation, community forums. All of that's there to help developers get up to speed quickly. And don't forget Marlowe. That's a much easier starting point, especially for those who aren't super familiar with Haskell.
So there are different ways to get started depending on your skill level. Let's talk about the future.
Okay.
You mentioned Cardano still being developed. What's coming up next? What can we expect to see?
Okay, so after Goguen, we have Boss Show. That phase is all about scaling and optimization. They're working on things like Hydra, which is a layer 2 scaling solution, and that's going to allow Cardano to handle even more transactions per second, but without sacrificing security or decentralization. It's all about getting Cardano ready for mainstream adoption.
So even with all these advancements, they're not stopping there. What about governance? Any cool developments happening there?
Yes, that's where Voltaire comes in. This phase is all about on-chain governance for Cardano. So the community will have a direct say in how the protocol develops. Imagine like ADA holders voting on proposals, funding projects, shaping the entire ecosystem.
That's incredible. It really sounds like Cardano's committed to building this decentralized and community-driven future. We've covered so much. I feel like I understand Cardano's journey and where they're headed so much better now.
And remember, this is just the start. Cardano's constantly evolving. Who knows what incredible innovations and applications are coming next?
I think it's time to wrap up our deep dive into Cardano's Goguen era. We've explored the foundations, the innovations, the challenges, the impact. Thank you for guiding us through it all. It's clear that Cardano is more than just another blockchain project. It's a movement, a community, a vision for something better. So to all our listeners out there, keep exploring, keep learning, keep asking questions. The world of blockchain is constantly evolving, and there's always something new to discover.
Thank you for being part of Cardano for Everyone. We hope you gained something valuable from today's episode. If you'd like to support our mission of making Cardano knowledge accessible for all, consider selecting Pasta from the pool list when you delegate. Every bit of support helps us bring more content to listeners like you. Until next time, keep exploring, keep learning, and we'll see you on the next episode.